Welcome to EDU World Space.
So this time we're given a new problem. It's We have two particles. Think about the x-axis. So this happens to be the origin, and there's a particle at the origin, and also the center of mass of the two particles. So this is one particle, and then another one is here. I'm just going to call this one A, the one at the origin where um, x equals to 0. That's the position. And then the second one, I'm going to call it B. Um, this is going to be B at x equals to 8.0 meters. This is just 0 meters. And then this is the center of mass that happens to be at x equals to 2.0 meters. And the the second particle, the B particle, happens to have a mass of um, 0.10 kilograms, and then the A particle, we don't know what the mass is for that one. So that's the information we're given. We're also told that the velocity of the system at the center of mass happens to be 5.0 meters per second I hat. That's the velocity of the system. So in part A, we want to find the mass of the particle at the origin. We want to find ma. And then in B, we want to find the total momentum, okay, p total of the system. That's the momentum of the system. And then in part C, we want to find the velocity of the particle at the origin. So VA, we're calling it VA. This is the velocity of the particle at origin. And so, we're going to do a stepwise process. Remember, we'll use the center of mass to resolve this problem. The center of mass happens when we're going to call that this should be called XC. So XC is the center of mass. So XC equals to MA plus XA plus MB times XB. So just to make sure the labels are right, this is XB, and this is XA, and this is XC. And so this is divided by MA plus MB. Okay, so that's what we're given. And so our goal is to solve for the mass of A. We'll multiply both sides by this value, so we get XC MA plus MB equals to MA plus XA plus MB XB. And so MA, we use distributive property right there. MAXC plus MB XC equals to MA plus XA plus MB XB. And then our goal again is to find MA, so we'll move this MA to this side, and then we'll move this to the right. So we have MA xc plus, or rather minus, because it's moving to the left. So this is going to be minus. This will be minus ma equals to xa plus mb xb minus mb xc. So we pull out the ma, and we're left with xc minus 1 equals to xa plus mb xb minus xc. Those are the positions we have. So we're getting closer to solving for ma. So we'll just shift to the next page and make sure that we have our numbers right. So ma xc minus 1 equals to xa plus mb xb minus xc. Recall that xa is the dimension at the origin right here. So that means it's 0. So xa is 0. So we're left with, we could divide both sides by xc minus 1 over xc minus 1. And so we end up with ma being equal to mb xb minus xc over xc minus 1. And so if we go back, we see that xb is 8.0 meters. Sorry, MB is 0.10 kilograms. So we need to change that real quick. So we need to change this one. This is MB, happens to be 0.10 kilograms, and then XB is 8.0 meters, and then XC is 2.0 meters, and then XC is 2.0 meters minus 1. Okay, 2.0 meters minus 1. And so if we simplify this problem, we get 0.1 times 6. So we get 0.6, the mass being 0.6 kilograms. So ma equals to 0.6 kilograms. So we just want to go back and make sure that we had our answers right. So we had M1, oh sorry, MA XA, so that would have made it XA 0, so this one, yeah, so we need to change some things here. So we had a plus, it shouldn't be a plus, it should be a multiplication instead of a plus. So this one right here, it's not a plus. This is a multiplication. So this one right here, it's a multiplication. So times, and then this one is times, and then this one is going to be times. And then when we move it to the other side, we don't have this one. We don't have this. So this becomes This becomes XA. Yes, this becomes XA right here. Okay, just remember that that's XA, MAXA. So when we simplify, this is going to be XA. Yes. And then we don't have this right here. Okay, so this is just minor corrections just to make sure that the math is right. And then when we go to the next page, this is XA. This is XA right here. And this is XA right here. And this is XA right here. Okay, so when we divide that, we end up with XA right here, but then XA is 0.0 meters. And so this is going to change to 0.3 kilograms. Okay, so this is 0.3 kilograms. And that happens to be the mass of A. So that's the first part of the problem. We're able to get the mass of A. The second part of the problem, we'll do it on the next page. And this time we're supposed to get the velocity at the origin. So velocity at the origin. We do know in terms of momentum is that the momentum of the system, m1 plus m2, this is common momentum, equals to, this is actually ma and mb. That's the velocity at the center of mass, this one right here. This one right here. So if we come back, we see that we have ma, va. VA, remember VA was the velocity that we're looking for, this one right here. And then VB is the velocity of the second one plus MB, VB. And so, V velocity at center of mass is equivalent to the individual momentum over the sum of the masses. And our goal is to get the velocity of A, so we're going to solve for that. And so VC MA plus MB equals to MAVA plus MB VB. Remember something else they said about the problem, and this was given. I think we should have mentioned that. The other particle is at rest, so that means we want to make sure that VB equals to 0 meters per second. So you want to remember that. We just don't know what VA is, and that's what we're trying to find out. So coming back to this, we get to see using distributive property, MA VCM, velocity at center of mass, plus MB VCM equals to MA VA plus MB VB. Going to the next page, we're going to simplify the problem because our target is to get VA. So we put the MA's, we get the VA, we put it by itself. So MA VA has to equal, if you look back, it has to equal MA VCM, like that, plus MB VCM. And then minus is going to be a minus because this one moves all the way to the left. So it's going to be a minus MBVB. MBVB. Okay, so VA has to equal to MA VCM plus MB VCM minus MB VB over VA. Remember, VCM is the velocity at the center of mass. And then you want to recall that so VCM is the velocity at the center of mass. And then VB is the velocity at B, and VA is the velocity at A. This should have been MA, sorry. So when we plug in the numbers, the mass of A verified, we already got that in the second part, is 0.3 kilograms, 0.3 kilograms, times the velocity at the center of mass, which is 5.0 meters per second I hat, plus mass of B. Mass of B happens to be, if we go back, 0.1 kilograms, 0.10 kilograms, times the velocity at center of mass, which is meters per second I hat, minus mass of B, 0.10 kilograms, times the velocity at B, which is 0 meters per second. And so this part of the equation will just disappear because it's going to be 0, and then all of that is divided by mass of A, which is 0.3 kilograms. When you simplify that, you get that the velocity of A happens to be 6.7 meters per second I hat. And just one clarification, this problem, this part should actually be part C. This is part C, the velocity of the particle at the origin. So we skipped the step in part B, but we're going to go back. Remember, part B was asking about the total momentum of the system, and so we'll do that on a new page. And so the total momentum of the system, which I'm calling P total, has to be M1, or rather MA plus MB, and then VCM. And so this is 0. The mass of A, we got that was 0. Coming back to the 0.3 kilograms, plus the mass of B, which was 0.10 kilograms, times the velocity at the center of mass, which happens to be 5.0 meters per second I hat. That's the total. So if you plug in those numbers, you get that the total momentum happens to be 3.3, 0.1, that's 0.4 and 5. So that gives us 2 kilogram meters per second. That's the total momentum of the system. Hope you enjoyed the problem. Looking forward to the next question, and if you have any questions, you can feel free to send them my way, and have a wonderful day. Okay, thanks, bye. And see, the velocity of A was 6.7 meters per second.